So we are doing lesson 9 this week after midterms. I hope everything went well for everyone. So winding down the semester, this is one of our last chapters. So this one's also a quick one, similar to the ANOVA. So when we're talking about chi-squared, the first thing we do want to touch on is the goodness of fit test. So really all this is talking about is when we have proportions, first of all. So like it says, two categorical variables. And we're trying to decide, we're trying to compare the two if they're independent of each other, categorical, and then obviously there'll be proportions then. So then the goodness of fit is just talking about them being, so testing if their proportions are all equal, or we can set a specific set of the proportions so we don't have to use all of them in that case. But yeah, that's the main idea there, just saying that, goodness of fit, we end up putting, we have our two independent groups on, our X and Y axis. So you have your categorical variable and then whatever the independent groups are, and then you're able to find between those two independent groups, excuse me, if there's some sort of, relationship between them based upon the goodness of fit. And then expected counts. This is basically, we talked a little bit about this before. It's basically what we would expect to get if we kept doing the trial over and over and over again. This is what we would expect to get at the end, which is basically, that's why it is our sample size n times our probability, so the hypothesized proportion. And you see it says like the ith group. It's literally just saying that that's going to be whatever the, the highest group. So if it was like, let's say n to p to I, if the I was like 6, that'd be the 6th probability that you have in that case, or the 6th proportion. So, so yeah, that's how you find that. And in reality, we have to make sure that an assumption that's met is that they all have to be at least 5. And in order for that distribution to be used for the chi-squared distribution there. So that's the main idea for expected counts. It's a pretty simple equation to figure out. We have used it before talking about a mean. So if you ever want to look back at that and make that connection, but that's the main idea for that. Okay, test statistic of a goodness of fit test. So we just talked about goodness of fit, remember, and basically a test statistic for that test, that's why we talked about first, is our chi-squared, which is where that comes from. So basically that is going to be the observed and expected values, that we use to find the chi-squared. So here we have observed minus expected squared divided by our expected. So that's the main idea that we do there. And this little thing on the side here, that just means the sum of. So in reality, that's why we usually use some sort of software to find the chi-squared test statistic, because you really would have to go through the sum of your observed minus expected squared divided by your expected, and do that for all the different observations that you have. Because remember, our chi-squared test is similar to residuals in the way that, so remember with residuals, you would have your graph, and then, this would be the, excuse me, like let's say this is the value that you thought you would get, so the x, but then like this is the value that you actually got, so that's like your sample x or whatever, so we could just say that's x bar or whatever. Then our residual was the in between it there, so it's a similar aspect there, because we still have, if we look at it this way, we have our observed, which would be this one, and then our expected, which would be the one that's on the line, and then divided by your expected again. So same idea there, just a different way that we use the equation. So yeah, okay, so once again, as we've been doing all semester, doing chi-squared, doing hypothesis testing, this is basically a very similar way, except we're just doing it for chi-squared tests of independence. So the first step, remember, we do have to check our assumptions and then write our null and alternative hypotheses. So our first assumption that we do have to check is that our sample has to be random. And then also, like I said earlier, when we're talking about expected values, they all have to be at least 5 in order for us to move forward. And then after we find them, after those are met, then we're able to find the null and alternative. So the main difference between the null and alternative and like our interpretations of them between this hypothesis test and others is that, we used to talk about, there being like a change, or like there being no change for the null, and then there being like a change for for the alternative here. So that's like the main difference that for here, when we're talking about for chi-squared tests, we're going to talk about our null being that they're independent, and then the alternative that they are dependent. Because as you see here, we're doing a chi-square test of independence, so we're trying to decide if there's a statistically significant relationship between the two categorical variables. And then whatever information we get is going to give you information in terms of like whether the relationship between the two categorical variables is likely or not. You know, and if it is likely, then they could be dependent on each other, so there is some sort of relationship, or independent means that they there's not a relationship going on there. So, all right, what else? All right, so yeah, our second step, always got to calculate the test statistic, and like we talked about earlier, we won't go too much more into it, is going to be our chi-squared. That's our test statistic that we do use in these tests. And once again, this is the sum of, and then here's the observed minus expected squared divided by our expected. And then if you're looking for, this E is telling you the expected cell count. So if you were, you know, a Minitab or something, and you had a bunch of different, you know, cells here and rows and whatever, and you wanted to find like this one specifically, you would literally have to go from that cell, and you would have to take the row total first. So whatever this number is, so that's going to be your row total. Well, I don't know why I can't speak. That's really fun. And then times your column total, which is going to be the one down here. So times the column total, and then divided by n, which is whatever your sample size is. So you're going to multiply these divided by n, whatever your sample size is. So you want, basically the idea here is that you're using, you know, the intersection here. Like your cell is the intersection between your row total and your column total, and that's how you would find the expected cell count for this one specific cell by hand. But like I said, we usually use software to do that. Okay, so then thirdly, we can determine our p-value based upon what we got. And then also remember that we talk about our degrees of freedom. We've talked about that before as n-1, but when we're talking about chi-square tests, you know, you see that we're having two groups, because we're talking about seeing if they're independent or not. So obviously you do have to have two groups then. But in that case, you do have your, when you're finding the degrees of freedom, you do the number of rows minus 1 times the number of columns minus 1. So it's a little bit different there. We're not using the sample size in this aspect, but this is going to be our degrees of freedom that we do use to help determine our p-value in that case. And then obviously after we find the p-value, we do have to make a decision based upon it if we're going to reject or fail to reject the null. Same idea as the rest of the hypothesis testing. This one really doesn't change for any of the hypothesis tests. So for the fourth one, you see if your p is less than alpha, then you're going to reject the null. And then if it's greater than alpha, you're going to fail to reject the null. Just as a reminder, hopefully that's pretty set in your mind by now. But so yeah, and then based on your decision, you go ahead and write the real working conclusion for your step 5 here. So nothing too complicated there. That's what we've been doing for basically the entire time we've been talking about hypothesis testing. Okay, and then I know we hadn't mentioned relative risk before, but this is, it's still relevant in this chapter, so I just want to review it quick. So our relative risk is where you're comparing the risk of a particular outcome in two different groups. So it's basically telling you the risk in group 1 as a multiple in the risk of group 2, which is why we have it set up like this, so we have risk in group 1 divided by risk in group 2. And then this gives you practical significance, which remember is different from statistical significance. Practical significance is more like real world, and it's like it's not just numbers. This kind of gives you more, I guess, quantitative like information about it. But like it says here, you know, your p-value gives you statistical significance, so that's where we either, you know, reject our null hypothesis or we fail to reject. But then if we do like that's our statistical significance, but then if we do relative risk, then we kind of have like practical significance that's more applicable to the real world. So this is just the equation you would use to find that. And then remember, risk in general is just basically the same as probability, you know, the probability of it happening divided by the entire chance there. So let's do some review questions. These are usually, it's usually more helpful, I think, in this chapter to do reviews than to just review the topics. But so let's try this one. So the table above summarizes by biological of the respondent to the responses from 1,033 adults to this question: do you smoke? What is the relative risk for female smoking compared to male smoking? So go ahead, try calculating this, and then we will go over it together. No question marks. Boo, be confident in your answers. So yeah, our answer is B. So let's go over this one. So remember, if we just talk about risk in general, we have our, if we're looking for just risk, let me just write it over here. So risk is just going to be our number with the outcome divided by the total. So then if we're talking about our risk in group 1, so I'm just going to say R1, that's going to be so the number with the outcome. So we're talking about female smoking compared to male smoking, and they're trying to figure out for do you smoke. So that's going to be those who say yes. So risk 1, since it's talking about females compared to males, risk 1, we're going to start with females. So we're going to say 171 is our numerator. And then divide it by our total, which is 589, because we're only looking at females right now, because we're only talking about group 1, which I can label here. So 589. So that's going to be our risk 1. And then we end up, then we can have our risk 2. And then we're talking about males. And then here you would do the same thing. The number with the outcome, so 142, divided by our total, which is 444. And in reality, what we're really doing here is just a big division between these two. So technically, if we solve this out, we're going to end up getting, actually, let me solve out the specific numbers. I don't have them. But so what we end up wanting to do, we have risk 1 divided by risk 2 to get our answer. So if we were to find the answer for risk 1, we have 171 divided by 589. So we get about 0.29. And then we divide that by our risk 2. So this was 0.29. And then our risk for the group 2 was our 142 divided by 444. You get about 0.32. I'm rounding by 2 decimals, but probably should round by 3, but too late. Whoops. But okay, the 0.32. And then if you were to go ahead and solve this, I'll just make sure. 0.2 divided by point. Yep. So you get about 0. If I would have rounded to 3 decimals, 908 in this case. So that's how we got the answer B here. Does that make sense how we got that answer through all of this? You know, why we were working with the yes people and the totals and whatnot? You guys seem to understand that one, so it's good. All right, cool. Let me know if you have any other questions. We will move on to another one. Okay, so conducting a chi-square test on 2 variables, a statistically significant relationship is illustrated when. So go ahead and read these descriptions and let me know what you think the answer is, and we will go over it together. Okay. All right. So let's look at this one. So let's think back to what our null and alternative hypotheses are telling us. So remember, when something's statistically significant, we're going to be in favor of our alternative hypothesis, which in terms of the chi-squared test is saying that they're dependent, that the two variables are dependent on one another. So there is a relationship. So basically, if we're thinking that there is a relationship, we're saying it's significant enough that we found it to be statistically significant. So not A or B. So we have to cross those out because this is saying it produces a small relationship, but that's not true because if we're in favor of the alternative, so if something's statistically significant, therefore we're in favor of the alternative, which is saying that there is a relationship. So we wouldn't want to choose either of those. So we're between C and D now. And then you want to decide, so it says that is either likely to have occurred even if there's no difference or is unlikely. So remember, once again, our alternative is saying that there's some sort of relationship. We think there's a difference going on. We think there's some sort of change. So that's why our answer has to be D, because it's saying produces a large relationship. So because because it would be unlikely to have occurred if there's no difference. I know, get out. The end. That's okay. No, this one's tricky. This is definitely a tricky one. Because you kind of have to look at each part of the question, So, first we can check that the large relationship part is correct because we're talking about there being a relationship, and then in terms because we're in favor of the alternative hypothesis, and then when you say that it's unlikely to have occurred even if there's no difference, that's basically saying like if there's no difference going on, remember when we talked about with p-values, it was like unlikely to have occurred to like with random sampling error. It's the same idea here that we're basically saying that if there is no difference in the population, like even if there isn't, this still would have happened, like because there's a large enough relationship that it doesn't matter in terms, even if there's no difference in the population. It's basically saying that this is statistically significant enough that we can make that conclusion there. So we, saying that it's likely to have occurred if there's no difference, that doesn't make sense because that's saying that like there's a relationship that occurred, like that relationship probably occurred, but really there's no relationship. D is saying that relationship occurred, there's a large relationship, and it's unlikely that we don't have a difference in the population, which is why we have a relationship. So there is a difference or a relationship there. So does that make sense how I explain that? It's definitely a tricky one. I know. I know, this chapter is super fun. But yeah. You can call it chi-squared, by the way. No, I'm just kidding. Don't do that. That's what I called it for like the first many times that I took this class. So, but chi-squared, statistics, nice. But yeah, okay. So our answer is D. Good job, guys. All right. I think we have two more. So here's our research question. Everyone last year got mad at me and they said that all I do is talk about food during my review. So I'm trying not to, but I'm sorry. Here's a food-related question. So is there a relationship between whether or not someone likes chocolate cupcakes or whether or not they like chocolate milk? Yeah, that's what I'm saying. Who is negative? Like, we're going to talk about food if we want to. So yeah, let's talk about chocolate and stuff. Yeah. So here's our study design. We have 200 participants. Each person is asked if they like chocolate cupcakes or if they like chocolate milk, both yes or no questions. So what is the statistical analysis that we should use for this data? So read through these and think about, given the information we have here, which one you would want to choose for these. And then we will go over it together. Don't be scared to answer. That's why I'm saying you have to be confident in your answers. So yes, everyone's correct. Good job, B. Because remember, so we're talking about categorical variables here because the yes or no. So that's our first step to check that. So we have categorical variables. So that means that we can definitely cross out C and D because those are talking about means, which remember, means go with quantitative variables, which we are not talking about. And then for A, it's saying one proportion Z test, so categorical can go with proportions, but we don't only have one here. We do have two. We have, the proportion of those like chocolate cupcakes and then the chocolate milk. So that's going to be that we have two proportions here. And in this case, they're trying to see if there's a relationship. So that's how you know it's not like a two proportion Z test or any of that, because they're trying to see the relationship. They're not just trying to compare them. They're trying to see if there's, if they're independent or dependent. So that's why it has to be B, because it's categorical, and it's talking about a relationship here. So you can see chi-square tests of independence, or basically, or we're saying if they're dependent on each other, which is what our alternative hypothesis is saying there. So good job. You guys got that one good. All right. All right, one more. So the table above shows the opinions of 953 respondents in the general social survey to the question, do you approve or disapprove of wiretapping? The purpose of the research is to examine the relationship between biological sex and the approval of wiretapping. What is the correct alternative hypothesis for this research study? So another practice in writing a alternative hypothesis. So try this one out and then we'll go over it together. Yay, good job. You guys definitely have a good hold on this. So yeah, our answer is C. Great job. So remember, first of all, what's the correct alternative hypothesis? Remember, our alternative hypothesis is always saying that there's some sort of change going on. And then in this case, when we're talking about chi-squared, we're talking about there being a relationship. And then if there is a relationship, then that means they are going to be dependent upon one another. And then, so if we go through these options, A and B are both saying that there's no relationship, so that's wrong. That's what our, this would actually be for our null hypothesis. You could write that. So we're talking about our alternative, though. So we're between C and D, and then you guys are doing great with this. You guys have done really good with this semester, making sure that we're writing these null and alternative hypotheses in terms of the population. So remember, that's what we're talking about here. Not our sample, because we're trying to make inferences about our population. That's why we would use P and not, P hat for if we were going to write these. So yeah, not our sample. So that's why C would be our answer here. So good job. You guys definitely understand that one. Okay. All right. So that's all we got for tonight. Like I said, it's a pretty short chapter. So go ahead and watch any YouTube's back, obviously. Now would probably be the time to start going back for the final and, reviewing the different chapters that we have done in the past and seeing, which ones you have questions on so that you could bring those to any Q&A sessions, with myself or Zach. I know Lydia's been helping us out with that too. So, we're all more than happy to help you out with that. So yeah, our next group review won't be for a little bit. I feel like we're breaking up, guys. We never see each other anymore, but so we're gonna see you guys again on Sunday on the 26th at 10 o'clock. So this will be after Thanksgiving. So yeah, I hope you guys have a great Thanksgiving. If you have any questions, let me know. If not, you're good to go for tonight.